Hey all, welcome to the last segment of graphing, talking about secant and cosecant, our last two functions, which happen to be the reciprocal functions of cosine and sine, respectively. So hopefully you remember how to graph sine and cosine very quickly now, because we're going to use those to then, since these are the reciprocal functions of those, graph secant and cosecant very quickly as well. So without further ado, let's do it. So as I mentioned, we're going to start by looking at the last two that we have yet to discuss, and that is secant and cosecant. Simply the reciprocal functions of sine and cosine. So remember, secant of an angle is equal to the reciprocal of cosine of that angle. And since we know secant is just merely the reciprocal of cosine, which is always the x over the r, then we know that secant is merely the r of the x. And so we'll get into that and the fact that we will now have issues in the denominator, unlike cosine previously. And also cosecant, which is the reciprocal function of sine. And remember, sine was always the y over the r. So cosecant, since it's the reciprocal, would be r over y, and therefore would also have issues, but when the y value is 0. Okay, so similarly, when we're talking about tangent and cotangent, and them having certain issues with the denominator being 0, these ones will also have those issues, and namely, like I showed you a minute ago, for cosecant when y is equal to 0, and for secant when x is equal to 0. Okay, and remember, when those are in play, we will say that they are undefined, and in order to show you that graphically, we will do the vertical asymptotes in those specific places. Okay, so we'll explore that. I'll talk a bit about that as well in more detail. And then the last thing I wanted to do in the notes here before we get going is talk about the parent graphs of both sine and cosine. If you don't know those like the back of your hand by now, then these are going to be even more difficult for you to come up with. So make sure you have those down pat before you move on to this section, because I'm going to review those with you right now. All right, so first things first, we'll go ahead and start with sine, which, remember, the sine of any angle was equal to y over r. But if we are on our unit circle, unit meaning one in every direction, then we can just say that our r will always be 1, and therefore we can just focus on the y values of these things. Okay, so for sine, we're just going to focus on the y values. And remember, we always start at that 0 degrees or 0 radians, and then we continue to move around from there by 90 or pi over 2. So 2 pi over 2's would be pi, 3 pi over 2, and 4 pi over 2's, which would be 2 pi. Okay, now with that, we remember these things, both sine and cosine, their functions oscillate from 1 to -1. So when we're going around the horn here, for our angle measurements, which is our input, the x value, so to speak, then we will get the output, which is our y value. Now remember, for sine, we're looking at only the y's. So for this, we know that we're going to start at 0 for our output. Then when we move up to pi over 2, we would have an output of 1, back to 0, down to -1, and then making our full circle of 2 pi or 360 degrees, we go back to 0. And of course, like we mentioned, we could do all the reference angles of 30, 45, and 60, which we should know by now, in every single one of our quadrants. But we already know that it would be the 30 would be the 1/2, the root 2 over 2, the root 3 over 2, and therefore it would look like that in every single one of our quadrants. So that is our sine curve, which we should know very quickly because we're just focusing on the y on the unit circle, which we know starts at 0, goes to 1, then back to 0, -1, and all the way back around to 0. Okay, so cosine is very similar with the exception of instead of the y values, we'll now be looking at the x values. So we know the cosine of any angle is equal to x over r, and again, since we're on the unit circle, we're looking at just the x values. Now remember, that's different than the angle x. We're talking about these ordered pairs, x comma y. So don't get those confused. Remember, x represents my angle because that's what's following my cosine, and therefore we're going to be using our standard radian measurements for our angles. Still oscillating from 1 to -1, then utilizing the fact that we know all of these angles to be certain outputs on our quadrantal angles, we call them, x and y axes. So this time we're going to be looking at the x's, which you can see at 0, it's going to start at 1. Then we're going to go to 0, -1, 0, and back to 1. If you notice, that looks a lot like our sine curve. It's actually just translated with a phase shift of pi over 2. Okay, so if we actually took every single one of these values from sine and shifted them left pi over 2, then we would have our cosine curve. And why pi over 2? Remember, pi over 2 is 90, and remember the name of this is cosine. They are complementary functions. Okay? So now that we have these down pat, we hopefully know boom, 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 boom. We draw this out. There's our cosine. Same thing here for sine. We draw that because if you know these, then when we talk about doing the reciprocal, so for this one, cosecant of some angle, and this one, secant of some angle, I will take each and every one of these quadrantal angle values, which this one would be 1 over 1, -1 over 1, 1 over 1, and then these would be the 0 over 1s that we would get from each one of these ordered pairs in our R, and we will flip them. So starting you off with the graph, and again, they can ask us to do more than one period. Hopefully they do not, but still going to oscillate between 1 and -1 because remember, if we're dealing with sine, we already know the graph of that. We already know the 1, 2, 3, 4 quarters that we should be dealing with. From 0, pi over 2, pi, 3 pi over 2, and 2 pi in either direction. And once we have those, and we lightly draw our graph for sine, which remember we said was the y value, so it starts at 0, then went to 1, 0, -1, and 0. Whether I start at -2 pi and go around, that is our sine curve for 2 periods to the left 2 pi and the right 2 pi. Now, why did I take the time to do that? Because this is not what they're going to give us. They're going to ask us to graph and draw this new function in this last section of this chapter. But remember, cosecant is merely just the reciprocal. And if I take all these 0 over 1s, which represented all my zeros, or the positive -1 over the radius of 1. Okay, when we take these and we actually do the reciprocal and we flip them to get our cosecants, then we know when we flip the positive -1 over 1, we still get that positive or -1. So that's not going to change. The reciprocal does not change the positive or negativeness of it. But when we flip the 0 over 1, that yields a 1 over 0. And that, my friends, is what we have to worry about. Because everywhere we see these zeros, here, 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 all these places, which was this, for our regular sine curve. When we do the reciprocal, we will have that 0 in the denominator. And what did we just get done reviewing in the last videos? Well, that is now going to mean we have vertical asymptotes everywhere there was a 0. Okay? So, of course, then what else do we have to do? Well, like we said, if we flipped our other ones, we still get those ones or negative ones. So that value, they will all stay the same. But remember, asymptotes are like borderlines. That means our graph is going to approach them. And remember, because it's the reciprocal and we virtually just flip our fraction, we can just take what we have here and flip it the other direction. Flip this one the other direction as well. And so that is, my friends, all there is to it, to graphing one period of cosecant. Now, yes, it still does take a period of 2 pi, just like sine did. Because notice that this is different than this. All of these are positive values where all of these are negative values. So if I was to draw a second period, I would have flipped this little parabola looking shape and this parabola looking shape. And hopefully you can see every 2 pi, this thing will repeat. Whether it's the positive 2 pi or the negative 2 pi. Okay? Now, one more thing just to make sure that you understand why we flip these is because remember, all students take calculus. That simply is our moniker that we remind ourselves what things are positive where. And since we're dealing with the sine function, just the reciprocal of it, the positive or negativeness will not change. So since we're dealing with sine, yes, all of this has to go and approach those positive, and all of these would have to be negative. And that's it. So let's take a look at example 2 and what we would do with secant then. So now we're dealing with cosine and secant. And like we said before, they are merely reciprocal functions of each other. So labeling our axes and then lightly graphing what we know cosine to be, which remember, cosine is always the x over r. And if we're on the unit circle, we're just worried about the x. And when we're at 0 degrees or radians, we know we are out an x value of 1. Then 0, -1, 0, and +1. And we can do that in reverse. 0, -1, 0, back to 1, to draw lightly here our cosine curve. Because remember, we are not actually going to be asked to graph cosine. We are going to be asked to graph the secant function, which remember is simply just r over x, which if this is 1, we're still just looking for the reciprocal of x. In all the places where it was 0 versus the 1, we know when we do the reciprocal, that will give us an issue with the 0 on bottom. So everywhere there was a 0, in the regular initial function of cosine, when we do the reciprocal, those will now yield undefined values for our output, which we then draw graphically, vertical asymptotes, we call them. Okay? The 1s and -1s, when we flip those, will still stay the same, either positive or -1. And therefore, this value will stay. This value will stay. All of those peaks and valleys will stay the same. However, everything else will also be reciprocated. So the 1/2s and things like that will now become, instead of 1/2 here, they'll jump up to 2 up here. Okay, so when we go to finish our graph of this, we will merely just flip each and every one of these little parabolas. And again, hopefully you can see that the period, since this is left pi over 2 and this is right pi over 2, that is not one period because it does not repeat to the next pi over there. So it's actually going to take, since this is pi and this is pi, it's going to take a total of 2 pi for our period again. Now, one thing I failed to mention on example 1 is, what about the amplitude? Those are some of the first two things that we talked about with sine and cosine. Well, remember, with the amplitude of sine and cosine, we had that peak and that valley, that high and that low, that max and that min, we call it, of 1 and -1. And from our x-axis, we said the amplitude was 1. Well, no longer is there an amplitude, just like with tangent and cotangent, because these actually go up and down forever. But again, even though there isn't officially an amplitude, I will still use that terminology of 1, because yes, indeed, of course, we can multiply this by 3 and stretch it to be 3 times as long vertically. And of course, we could also do it to the x's as well. We'll get to that, but hopefully you all see how simple this can be when graphing, as long as you know your original function of either sine or cosine. All we're going to do is take the zeros and make those our asymptotes, keep our 1s and -1s, and flip everything else to be the other direction. So remember, you should not have in your final answer either of those pieces. This would be what your final product looks like, over one period or multiple. Okay? Not too bad. Hopefully you guys are getting a little bit more comfortable with these graphs, because now I'm going to change it up on you and throw some A, B, C's, and D's, or even some reflections. But before we do that, I wanted to make sure I gave you everything in concise, nice little place for your notes. If you wanted any of this, take a screenshot, grab these notes. All of the different parts that we talked about are on here, like where the issues are for each of these, which hopefully you see coincide with either the cosine or the sine values. Then we talked about the periods being the same. These actually don't have x-intercepts, so that's a key. And then there's no amplitude because of the min and max values not being there. So hopefully you are feeling pretty good about this last section of graphing here before we move on to the shifting and translations that they can throw at us with these new cosecant and secant functions.